This is Unit I, Lesson 1, Probability of a Simple Event. This will coincide with Florida Virtual Module 6.01. And we're looking at how is the probability of an event and its complement related. So there's quite a bit of vocabulary here for you to know. The first one here, what is a ratio that compares the number of favorable outcomes to the number of possible outcomes? So when we're looking at this, this is actually the probability. The next one, we're looking for the vocabulary word that is one outcome or collection of outcomes. And that's going to be a simple event. So that's rolling a dice or flipping a coin, spinning a spinner once. That's just one simple event. The next one, what is a possible result in a probability experiment? And a possible result would be an outcome. And there we go, the next word, outcome. So outcomes occur this way if each outcome is equally likely to occur. And that's only if it's random, and we're going to hear this again when we get into statistics. And the last vocabulary term. Blank are two events in which either one or the other must happen, but they cannot happen at the same time. And this goes back to when we were talking about angles, two angles that equal 90 degrees. They are complementary. Well, here, these are two events that complement one another. So these are complementary events. Next. So the probability of a chance event is a number between blank and blank. So when we're looking at this number line, it goes from 0 to 1. And this expresses the likelihood. And when you're explaining or answering questions, you need to describe the likelihood of that event occurring. So 0 being that it's impossible to happen, 1 or 100% being completely certain that it will happen. And then right here we know 50-50 is half or 0.5. It's as likely to happen as it is not to happen. And then anything in here between 0 and a half is unlikely to happen. Anything just above half and just under 1 is going to be likely to happen, but not certain, and not like a 50-50 is likely to happen as not happen. At the bottom, this P with the parentheses event, this is read as the probability of the event occurring. So that P just means probability. And this is the number of favorable outcomes to the number of possible outcomes. So on the try it, if you toss a coin, what's the probability of that coin landing on heads? And it's going to ask you to express your answer as a fraction, a percent, and as a decimal. So we're looking at finding a ratio of heads to both sides. So we know that as a fraction, there's one side that's heads, and then there's two sides to the coin. As a percent, we know that's 50%. And as a decimal, it's going to be 0.5. You're going to find it's probably easier to convert from the fraction to the decimal and then to the percentage. Lastly, or next, B, I should say.
Ow.
B, the spinner at the right is spun once. Find the probability of each event. Write each answer as a fraction, percent, and decimal. So when you're looking at the spinner, you want to count how many sectors there are, which there are 10 of those wedges. So B, what is the probability of spinning F? Well, the probability of F, there's only one F out of the 10. Again, it's easier to start with the fraction, then the decimal, which is, again, 1/10, and then move it 2 to the right, and it's 10%. D or G? Well, there's a 1D, the 1G, which is 2 out of 10, or simplified to 1/5. Change this to a decimal, 2/10, and then as a percentage. Lastly, the vowels. Remember, vowels are A, E, I, O, U. So I have A, E, and I. So there's 3 out of the 10, which is 3/10, or 30%. So if we were to describe the likelihood, they are all unlikely to happen. Or occur. And the last section here, so complementary events. So complementary, again, are two events in which either one or the other must happen, but they cannot happen at the same time. For example, a coin can either land on heads or not land on heads. The sum of the probability of an event and its complement is 1 or 100, meaning if you're adding your decimals, if you have it expressed as a decimal, let me move that up. If you have it expressed as a decimal, it's going to equal 1. If you have it expressed as percentages, the sum will be 100. So we have a bag that contains 5 blue, 8 red, and 7 green marbles. A marble is selected at random. Find the probability the marble is not red. So when we write this probability, you're going to use the italicized P, and then we would write not red. So this is its complement. So we know that there are 20 marbles in all, and we're looking at not red, so blue plus the green, which is 12. 12 out of 20 when you divide, it's going to give you 0.6. An easy conversion to percentages, 60%. So when we look at this probability, theoretically, it is likely to not pull a red marble. So on our reflection, when you go back and you read the lesson's essential question, again, how is the probability of an event and its complement related? So here, the probability of an event occurring or its complement occurring is certain or not certain. So when we come back up here, we know that the complement is the sum of the probabilities and its complement, which is 100%, and 100% is certain to occur. And using that, knowing if there's 30% chance of rain, then the complement is a blank percent of no rain. So if you're not sure, we're just taking that 100%, subtracting the 30%, and we get 70% no rain. Unit I, Lesson 2, Theoretical and Experimental Probability. This mirrors the Florida Virtual Module 6.01. The essential question here is how are experimental probability and theoretical probability alike? You're also going to look at how they're different. The vocabulary on this is really what we're going to go over, and then there's experiments for you to do to compare to the theoretical. The Florida Virtual is going to ask you to do the same thing to submit. So this is going to give you a good idea of how you need to answer those questions. So the first vocabulary that I went through with the Zoom class is that uniform probability model. And it's where each outcome has an equal probability of happening. Uniform being they're all the same. So when you look at heads and tails, you have equal chance of getting heads or tails. If you have a spinner and it's broken into 4 parts, each of those sections is 90 degrees in the circle. So each outcome is as likely as the next. The next one is our theoretical probability, and it is what should happen when conducting a probability experiment, and it is based on the uniform probability model. For the next vocabulary, what is the ratio of the number of experimental successes to the number of experimental attempts? And I will say that this vocabulary term is used in one of your quiz problems. So this is the relative frequency. Next is what actually occurs. And let me underline, and I'm going to put that. Experimental frequency. This is high tech, isn't it, guys? So this is what actually occurs during such an experiment, and it is based on relative frequency. And this is where I've seen some students kind of getting tripped up with relative and what it the experimental is based on. And one experiment in a series of successive experiments, and you probably will remember this if you're not sure from science and doing your science experiments. This term is trial. And a trial is just one experiment in a series of experiments. So at the bottom, remember, theoretical is what should happen, and experimental probability is what actually happened. So the next thing you have on the next page is experimental lab. And again, you're going to have to do this on the quiz, so this is good practice. Coin toss, heads and tails, spinner winner, which goes with this. 20 trials, landing on B or not B. And to do this, all you need is a paper clip and a pencil and you will just take and spin it. So my first attempt was an A, and then you want to tally it, and you want 20 tallies, 20 tries. And then you also have these questions to answer, and then double dice. And if you don't have 2 dice, then you'll find there is a link to a Google spinner, dice, and coin toss even, if you don't have a coin. And you can use that to do random trials. Once you're done with that lab and you've recorded your data, then you have another page where you're going to fill in, pull this out, your theoretical fraction, decimal, and percent for the coin toss, and then experimentally, and that should say heads, that's a typo. What was your probability experimentally with your heads? So fraction, decimal, and a percent, that relative frequency. And then again for the spinner, and then also the double dice, double or not double. You have a reflection here, and you need to predict for the coin toss, spinner, and dice roll. What do you think would happen based on your experiment? Not theoretically, but your experimental probability. And then lastly, you should find this concept check just to kind of sum up what are the similarities and differences between theoretical probability. And it does say here group experiment, so if you come into Zoom, then we can kind of take a look at what happens when we average those probabilities together. Do you think it gets closer to the theoretical, or does it get further away from the theoretical? And which probability from your experiments do you believe is the most accurate reflection of the real world probability in the activities, and why? If you have any questions, please email me, send me a message through the announcements if you'd like, and have fun.